In this video, I want to show how to use R and RStudio for the negative binomial distribution. The command that we need is dn_binom, and then we need three variables, x, r, and p. The value of x is the total number of times I hope to complete the experiment. R is the number of successes. Let's suppose I want the 15th trial to give me the third success. And then p, let's suppose my probability of success is 0.2. We can then run this command, and we get a probability of 0.0382806. We could also do a range. Here I want the negative binomial distribution. This time I'm going to let x be between 10 and 15, so I want the third success to happen somewhere between the 10th and 15th trial. And if we run this, we get the probability that it happens in the 10th, 11th, 12th, 13th, 14th, and 15th. I can then use the sum command of that sequence of negative binomials, and it'll add it together to give me a probability of 0.287 that the third success is going to happen between the 10th and 15th trials. Next, let's look at the probability mass function and what these look like for a negative binomial distribution. Let's suppose we want between 0 and 120 trials. We want to know when our fifth success will occur, and the probability of success is 0.4. We can see this trial here. We expect to hit 5 really early on. You can see the probability peaks right here, right around 10. And then it's going to stagger down, and when we get to the 120th trial, it's virtually non-existent that we have not already reached our fifth success. Next, I want to change the value of R. Instead of hoping that we're looking for the fifth success, we want to see the 10th success, and let's see how that changes this graph of the PMF. We can see that it shifts the graph over slightly. However, overall, it does not change the general shape. It just kind of shifted over further to the right. Finally, let's look at how changing the probability of success affects this graph. And we can see this one changes much more drastically. First off, it doesn't go near as high. The peak's not near as high. It's much more spread out and open. So changing the value of the probability kind of changes the skewness of the graph, whereas changing the number of trials, the number of successes we hope to get, just kind of shifts the graph left and right.